Assalamu alaikum and welcome to lecture number 19. In this lecture and in the following lecture we are going to discuss the system description by linear constant coefficient differential and difference equations. Linear constant coefficient differential and difference equations, that means the constant coefficient differential equations are used for the continuous time systems, whereas difference equations are used for the discrete time systems. And representing LTI systems using the constant coefficient difference and differential equations provides another representation. Differential equations, as I said, are used to represent continuous time systems, whereas difference equations are used to represent the discrete time systems. The general form of the differential equations or differential and difference equations respectively are summation k running from 0 up to n ak dk over dtk y of t equals to summation k running from 0 up to m bk dk dtk x of t. This is for this generalized differential equation for representing the continuous time system, whereas the generalized difference equation for the discrete time case is summation k running from 0 up to n ak y of n minus k, and this is equal to the input side, which is summation k running from 0 up to m bk x of n minus k. The integer n basically shows the order of differential or difference equation. This corresponds to the highest derivative or the maximum memory highest derivative in case of continuous time system, because this shows the highest derivative, whereas in case of discrete time system the maximum memory involving the system output is represented by n. So for example, if it has memory up to say 5, then k running from 0 up to 5, so 5 represents the maximum memory involving. Similarly, if you have a differential equation that has derivative up to 10, so 10 will be the highest corresponding derivative. Here the order represents the number of energy storage devices. For example, consider Rlc circuit as shown here. So the input is x of t, whereas the output is y of t. So here we are taking the current as the output. So input is voltage and output is current. So we can write this circuit in terms of linear constant coefficient differential equation as ry of t plus L dy of t by dt plus 1 by c integration minus infinity to t y of tau d tau. And you understand y of tau is basically the total amount of current flowing in the circuit. So this is equal to x of t, which is the applied voltage. Now to solve the difference or differential equation, the summation consists of two main components such as y of h and y of p. You understand here we have ignored the argument n or t because this notation is for generalized case, whether you have the discrete time system or the continuous time system. So we can write it separately also. So for continuous time system we can write y of t equals to yh of t plus yp of t, and similarly for discrete time case we can write yn equals to yhn plus yp n, right, where H represents the homogeneous solution and P represents the particular solution. So what is homogeneous solution? Homogeneous solution of the differential or difference equation is obtained by setting all the terms involving the input to 0. So if we let all the terms involving input into 0, the solution we can obtain is the homogeneous solution. And if you look at the previous equation of the differential equation, right? So here the input is x of t. So if we replace x of t by 0, so we get this equation, which we denote by equation 1. So for example, we have first order differential equation, for example this one, so and this is equal to t. So to obtain the homogeneous solution, we replace y of t by y of h, and similarly the input is replaced with 0 as shown here. So another thing important about the homogeneous solution is we have another equation that, so the first step is to replace the inputs by 0. The homogeneous solution for a continuous time system is of the form this one, which is denoted by equation 2. Here we need to find the R values, and Ri's or R values are the nth roots of the system's characteristic equation, which is written here. So these are the three main things that we need to do for the finding homogeneous solution. So on the next slides we have some numerical problems to clear the concepts that how we are going to find the homogeneous solutions, right? So in this example problem, we are given is electronic circuit containing R and C, and we have to find the homogeneous solution for this circuit or this system. It is given that x of t is input and y of t is output. So let's write the differential equation for this circuit first. So we know x of t is the input voltage, and y of t, which is taken across the capacitor, is output of the output, that is also voltage. So x of t is voltage, y of t is voltage, and the current flowing in this circuit is IT, right? So we can say that x of t, which is the input voltage, it is given, this is equal to the voltage drop across the resistor and the voltage drop across the resistor. So the voltage drop across resistor is given as IE, right? Current times the resistance, and voltage drop across the capacitor is Y of t, right? So the current flowing in the circuit is IT, and you know IT, if I can say that Y of t, which is voltage drop across the capacitor, equals to 1 over C into integration from minus infinity up to t, and this is I of tau d tau. So taking the differentiation of both sides will result into, so we get expression for the current in the circuit I of t equals to C dy t of by d by t. Okay, so putting it here, we get x of t equals to Rc times. So we can write that Rc, right? So I've just written this as first term, and so we can write the first term, this one here, and followed by this term, and we can equate it to 0, because to obtain the homogeneous solution, we make zeros input, right? So all the terms involving inputs are set to 0. So that means this is our equation for. So because we are finding the homogeneous equation, so I'll replace a subscript h here, right? So that signifies this is homogeneous solution, so it will be h of t, and again I'll write here h, right? So that it signifies this is homogeneous solution. So that's why subscript t. So I hope you're clear, right? Now to find the Ri's, which are the roots of the system, I equate this with the equation number 1. So if I compare this one with equation 1, I can find that. So if I compare, that means the coefficient of yht is 1. So I can say that using this equation, right, that means a naught equals to 1, right, and a1 equals to Rc. This is the coefficient of the first derivative, right? Now to find the roots of characteristic equation, we have a naught or naught plus a1 r1. That's all right, because it's the first order equation, right? So and here is 1, so it can go up to 1. So replacing value here and equating this to 0. So if we replace value here, so r power 0 will be 1, a naught is already 1, so it will be something like 1 plus Rc, right, times r, this is equal to 0. So that means r here equals to, right, so this is basically r1, right? So r1 equals to this. So if we put it in the equation 2, we get the homogeneous solution. Okay, so we get y yht equals to c1 e power. So we have, because n equals to 1, so that's r1. So this r1, so replacing it here, right? So r1 t, so it will be minus 1 by Rc into t. So this is the homogeneous solution for this equation. Let's consider another example. Here we have a system, second order system, right? So we have n equals to 2, and this is the equation for the system, and we have to find the homogeneous solution. So comparing with equation 1, we can find that a naught, right, this is basically I think plus sign is missing here, so okay, now it's fine. So if we compare with the equation 1, we can find that a naught basically equals to 2, a1 equals to 3, and a1 is this one, so a2 equals to 1 again, right? So you understand, to find the homogeneous solution, we need to equate this one to 0. So I equate it to 0. That means this is equal to 0, right? So I cross if this is equal to 0, so we get this expression, right? So the characteristic equation will be something like, you see, putting value here, it will be just so we get the characteristic equation a naught plus a1 r plus a2 r square equals to 0, because it's a second order, so the power can be up to 2. So by putting values of a naught, a1 and a2 in this equation, we can write that this is basically okay, this is equal to 2 plus a1 is 3, so 3r plus a2 is 1, so it will be r square, and this is equal to 0. So we can make factor of it, so we can say, okay, 2 plus, I can write it as 2r plus r, and this one can be written as r square, right? So we have 2 common in this term. Okay, you understand, 2 common is here and r common is here, so if I take this common, I'll get 2, and then this will be 1 plus r. Again, we can take r common, so I have 1 plus r, and this holds equals to 0. So solving for r, it will result into you understand, r equals to either -1. I hope you can solve, or okay, let me do it. So we found r equals to -1 and r equals to -2. Okay, so these are the two values that we have found for r. Now putting it in equation 2, we get y of homogeneous, right? This is equal to it will be c1 e power minus t plus c2 e power minus 2t. So this is the solution for this differential equation. Okay, so I think as a homework I give you one problem, and it is as shown here. So this is your homework problem, you can do it by yourself. Okay, so you're given dt, in fact this is dt square, right, not this one. So this is a second order, right, and then we have this one plus y of t, this equals to 2x of t plus d upon dt of x. So this is your homework problem. Okay, try it by yourself, and if you have any confusion you can ask. The second part is called the particular solution. Okay, and it represents any solution of the differential or the difference equation for the given input. It is not unique, so we are representing here y equals to y of h plus y subscript of p. So it means that we are talking about the generalized case. It can be discrete time or it can be continuous time. That's why I haven't mentioned here its argument. So it is usually the particular solution is usually obtained by assuming an output of the same general form as the input. For example, if the input is alpha power t, so we assume that output is c, or scaled version of the input, right? So c alpha t, and we need to find c. Similarly, for the discrete time case, we say x, if the input x of n equals to alpha power n, so the output will be c alpha power n. And similar to the continuous time case, we need to find the c. If the input is sinusoidal, so the output will consist of two parts, c1 cos omega naught t and plus phi, and similarly plus c2 sine omega naught t plus phi. So similarly for the discrete time case. So let's consider an example. So for example, we have the same circuit as we have discussed previously, and we have to find the particular solution, right? In the first case, for the homogeneous, we say, okay, the inputs are 0, right? Now we have to determine the y of p when the input is cos omega naught t. So we assume y of t, okay, y of pt, p for particular, right? So y of pt, because the input is sinusoidal, so the output will be like c1 cos omega naught t plus c2 sine omega naught t. Okay. The differential equation for this circuit is given by, we have done this in the previous example. We are going to find the homogeneous solution. So this is in fact y of t. This we have already done. Let's for simplicity say that derivative is represented by primes, right? So this is basically y of t. So right, so let's represent this by y prime of t. Okay, so y prime of t means first derivative of y of t. Okay, so that means ypt. So if I replace y of t by ypt, so I can write that ypt plus y prime pt, right? And also we have rc, which I forgot. So rc, this is rc times, okay, so this is equal to x of t. So if I replace ypt by this value, right, that is sine c1 sine omega naught t. Okay, so I put the values here. So that means for you see that this is ypt into derivative of rc times ypt equals to x of t. So ypt we assume is equal to c1 cos omega naught t, right, plus c2 sine omega naught t. Okay, so if I replace here, so ypt is equal to this. So this is the value of ypt. Then we have rc times the derivative of ypt. So RC times derivative of this, it will be equal to C1 RC C1 sine omega naught t, and when I take the derivative of sine, the derivative of sine, actually I have written in reverse. Basically this is plus, because derivative of sine is plus cos, right? Yeah, one more thing I forgot is into omega naught t. Let me correct it. So derivative of c1 cos omega naught t will be c1 omega naught sine omega naught t, but if with minus sign, right? And rc is already there, so it will be minus omega naught rc c1 sine omega naught t, and plus derivative of sine is cos, so it will be rc c2 and omega naught, because again derivative, so it will be omega naught rc c2 cos omega naught t equals to cos omega naught t. Okay, now we equate the coefficients, right? So equating the coefficients of cos omega naught t, so the coefficient of this is, right, equating coefficients, right, of the cos omega naught t. So it is c1 here plus is it plus? Yes, plus, again this is right, this is cos omega naught t, we have two terms, and again this is cos omega naught t, so we have three terms. So that means c1, and this one is plus omega naught t, omega naught rc c2, and this is equal to, what is the coefficient of cos omega naught t here? So it is equal to 1. Similarly, coefficients of sine omega naught, so let I highlight it with orange. So the coefficient, the terms are here, this one, at this side this is again. On the right hand side there is no sine term, so that means we can say that there is basically sine term with coefficient equal to 0. So if I write it like this, it will be c2, right, c2 and minus omega naught rc and c1, and this is equal to 0. Okay, so we can, in this way we can find the values of c1 and c2. You understand, we have two unknowns, that is c1 and c2, and we have two equations, so we can solve it very easily. So that means let's do it on the next slide. So by solving the coefficient, we get the values of c1 and c2, which are, so we get the coefficient value c1 and c2 to be these. Okay, and the particular solution will be ypt equals to, it was c1 cos omega naught t, so c1 equals to this one. I hope you can quickly I will quickly replace, and I hope you understand. So by putting the values of c1 and c2, we get the particular solution, and this is equal to 1 over 1 plus rc omega naught whole square cos omega naught t plus rc omega naught upon 1 plus rc omega naught whole square into sine omega naught t. What will be the unit of ypt? So if you recall ypt, look at the circuit. So ypt is basically output voltage, so its unit will be volts. So this is the particular solution. Okay, so let's consider one more example. Here we are given the input, which is equal to x of t which is equal to e power minus t, and the given system is double derivative of, right, now y of t plus 5 double derivative of y of single derivative of y of t, and plus 6yt, and which is given as, which is equal to 2xt plus dx upon dt, right? So I hope you understand this is the differential equation, right? And it's a second order equation, and we have to find the particular solution for this equation. And you understand, in particular solution we need the input signal, and we assume that the output is similar to input, or right. So let's assume that, because it's the exponential signal, so let's assume that the particular solution will be something like c e power minus t, right? So the first step we do is we replace the y of t with y of p in the given differential equation. So it has been replaced here, right? This is the first step. And then we also put, instead of x of t, which is generalized, we give it the particular input we have. So for x of t equals to e power minus t, so I write 2 into e power minus t because 2 is already in the equation, and then we take the first derivative of the equation, so e power t, right? Now replacing value of the y of p in the equation, right? So y of p equals to y of pt equals to c e power minus t, which we have assumed. So we put the value of it in the equation, and by solving we see that it's a double derivative, so it will be equal to c e power, let me change the color, so we get c e power minus t. You understand, if you take the derivative of this, it will be power minus t, and if you right, and minus 1 you take, so it will be minus c e power minus t, and because it's a double derivative, so if you take derivative again, it will be again minus 1 time, minus 1 times this, so minus minus becomes plus, then plus e 5 times c e power minus t, so it will result into minus 5 c and e power minus t, and plus 6 c e power minus t, and the right hand side is 2 e power minus t, and the derivative of this will be e power minus t is basically minus e power minus t. You understand why minus comes here, because it's e power minus t, e power t derivative is e power t, and because it's other than plus 1, so we differentiate again and it will result into minus. So if you look at this one, we can just cancel the e power t, because e power t is common to both sides. So let me write it, e power minus t, I take common, so what I'm left is c minus 5c plus 6c, right? And this is equal to, so this is taking e common again from this side, this is 2 e power minus t minus minus e power t, so 2 minus 1 is 1, so e power minus t comes here, so taking this one, right? So we can cancel the 2, so we get 1 on this side, so that means 5c plus c is plus 6c is 7c, 7 minus 5 is 2c, so that means 2c equals to 1, so it says that c equals to basically 1 by 2. So the particular solution will be replacing value here. For c we get ypt, right? Ypt equals to 1 by 2 e power minus t. So this is the particular solution for this differential equation for a given input of x of t equals to -1. So let's consider another example on discrete time. In this case, we are given the difference equation, which is y of n minus rho times y of n minus 1, that is the previous value of the output, and this is equal to x of n. So because in case of particular solution, we are given the we are provided the input, or we are given the input. So in this case, we are given x of n equals to 1 over 2 power n. So based on this input, we assume that the output y of p, the particular solution, will be equal to some scaled version of this input. So we say, okay, y of p equals to c 1 by 2 power n, right? Okay, so the second step is that we replace y by yp in the given difference equation. So we have replaced here, right? So if you compare this original equation, so now you can notice that y has been replaced with y of p, like we do for the particular solution. In case of this continuous time, we have done this. So this example is on discrete time, so similar procedure applies to the discrete time system also. So we have replaced here, right? And then we also replace the value of x of n by 1 by 2 power n. Okay, so the third step is that we replace the value of the y of p by the value we have assumed. So we have assumed that y of p equals to c 1 over 2 n. So by replacing the value, so y of p n is replaced with c 1 over 2 n minus rho, right, y of p minus 1, so it will become 2 power n minus 1, and this is equal to 1 over 2 power n. So by simplification, we can observe, we can take out 1 over 2 power n common, right? So if I take 1 over 2 power n common, let me change the color of the ink. So I have 1 over 2 power n common. So if I take common, what I'm left here is something like c and minus rho c, right? And because this is 1 over 2 power n minus 1, so you understand 1 over 2 power n minus 1 can be written as 1 over 2 power n multiplied by 2 power minus 1. So we can write 1 over 2 power n minus 1 equals to, because you see 2 power minus 1 is double divided, so we can write it like 2 by 2 power n. So if I replace here, I can see that 2 power minus 1 is basically, now I have taken out this 1 over 2 power n, so I am left here with 2. Okay, so that is, so cancelling the 2, right, this cancels with this one, so that means we are left with, if I take c common again, so I am left with 1 minus rho, and this is equal to 1, so that means c equals to 1 over 1 minus rho. So because now we have found the value of the coefficient C, so replacing this in the original equation, we can see that y of p, or the particular solution of this discrete time difference equation, is y of n equals to 1 over 1 minus rho into 1 over 2 power n. So this is the particular solution for this difference equation. So before giving you homework, let's consider one more problem on numerical problem on discrete time. So this is the difference equation, and this is the input, and we have to find the particular solution for this problem. So again, we assume that y of n will be, the first step is, right, the assumption about the output. So that's we just assume that this is equal to c into 1 by 2 power n, right? So this is our particular solution. So the second step is that we replace this by y of p. So we say, okay, y of p n plus 1 by 4 y of p n minus 2, right? And this is equal to x of n. So x of n is 1 by 2 power n plus 2 times x of n minus 2. So it will be 1 over 2 power, you understand, n minus 2 means you replace n with n minus 2, so we get this thing. Okay, so the next step is that we replace the value of y of p. So y of p is this one, so if we replace, we get c into 1 by 2 power n plus 1 by 4 c 1 by 2 power n minus 2, and this is equal to 1 by 2 power n plus so taking common 1 by 2 power n, right? So I take this 1 by 2 power n common, so I am left here is c, right? So this taken common plus c by 4, and because it's 1 by 2 n minus 1 by 2, so I can write here so I've taken 1 by 2 power n common, so I am because we already have here 1 by 2 power n, so we are left here with just c, and because we have here c 1 by 2 power n minus 1, so you understand 1 by 2 power n minus 1 can be written as not minus 1, in fact minus 2. So this we can write as 1 by 2 power n into 1 by 2 power minus 2, right? So that's why we have taken this one common, so we are left with 1 by 2 power minus 2, and again here also we are left with 1 by 2 power in fact minus 2, right? So 1 by 2 power minus 2 is basically equal to how much? 1 by 2 power minus 2, right? So if I bring it up, it will be 2 power minus 1, right? And this is minus 2, so this will become minus minus plus 2 power 2, and 2 power 2 is basically 4. So I cancel these two, and this will be C plus, this is 4, right? So 4, okay, right here again, C by 4 into 4, and this is equal to 1 plus 2 into 4, right? So 4 cancels with 4, C plus C is basically 2C, and this is equal to 2 4s are 8 plus 1 9, so that means C equals to 9 by 4. So that means the particular solution, that is y of p n for this difference equation is 9 by 4 times 1 by 2 to the power n. So with this we conclude today's lecture. I give you some homework, numerical problems.